Yes. So yeah, as Chris said, my name's John Ritchie. I'm an engineer, and I'm going to talk about what I do as a job. I'll also quickly run through how I managed to get to where I am from my time at school, what my job involves, what I like about it, and hopefully you can get a better insight of what an engineer actually does. So I'm going to start by taking you back a few years to when I was at primary school. Now, this is my primary school here, Lothermere Primary. It still looks much the same as that, although it was a few years ago that I was there. And this is a picture of my old football team when I was at school. And this is a slightly younger version of me playing in goals. At that time, I didn't really know what I wanted to do for a job. I hadn't had much exposure to different types of jobs, and certainly didn't really know what an engineer did. But at that time, I guess I did know that I liked science. I was pretty good at maths, and those are the sorts of subjects that I like doing. As I moved on to secondary school, I guess I had a bit more of an idea of what an engineer did, and it seemed to suit me. I'd maybe heard a bit more about it, but still didn't really know exactly what was involved. But again, maths and science were the subjects that I liked doing. I seemed to be quite good at them, and they were the ones that I most enjoyed doing as well. Also liked computer studies, and well, at the time it was called graphic communication, but it was basically just a fancy way of saying drawing technical drawings, this sort of thing here. These were all the sorts of subjects that I liked doing. But I suppose while I was at secondary school, that was when I really realised that there's actually lots of different types of things that engineers do, and I still wasn't really sure which of these would suit me. So some of the types of jobs that engineers have, well, you've got electrical engineers, so they might design your phone, they look at how computers and circuits work. You've got civil engineers who tend to build big things, buildings, roads, and bridges. You've got a manufacturing engineer who might look at how a factory is set out, what machines are involved, and how to make things. A mechanical engineer who'd look at how things work, from a pair of scissors all the way up to a massive oil rig. Now, through secondary school, I thought actually civil engineering was what I probably would like to do. I really liked the idea of building big things like bridges, buildings. That seemed to really suit me. But when I was in my last year of secondary school and looking for what I would want to do, maybe go to university, I changed my mind actually and decided I'd want to do a bit of a combination of all of them. And I think that's really one of the good things about engineering, is that there's so much variety in terms of what jobs you can do, what products and fields you can be involved in. That actually that was really interesting to me, and hopefully I can show you some of the sorts of things that are involved as I go through some of the jobs I've had. So after finishing at secondary school, I decided to spend another 5 years studying at university. Now, this is quite common for engineering, although there's other engineers who start work straight from school and don't go to university. But I went to university of Strathclyde in Glasgow. Now, while I was at university, I actually had my first taste of engineering as a job, where I worked for Ford. I'm sure you recognise Ford, who make cars. Among some of the projects I got to do while I was there was testing the Ford Cougar, which was brand new at the time. And I had to do things like check that the engine wasn't going to get too hot while you were driving, or that bits of the car wouldn't fall off. A different project was to look at one of their big factories where they made the engines for the car. Now, I had to try and work out how much it cost to make different combinations of engines. So how much more did it cost the factory to make 2 engines instead of 1? Now, it maybe doesn't sound like much, but actually the difference could be several £1,000,000. So actually it really was quite important to know. And as I said, this gave me a real taste for engineering, and I decided, yeah, this is definitely something that I'd like to do a bit more of. Now, when I finished at university after 5 years, my first job after graduating was to work for a company called CNH, or Case New Holland, and I was a mechanical engineer. Now, Case New Holland made tractors like this one here. I worked in an office that looked a little bit like this. There were 60 people, all mechanical engineers like myself, and all doing similar jobs to me. But right next to the office, there was a factory where they actually made the tractors, and a production line where all the tractors were built. And it was great to be able to go and see this. I could just walk out of the office and go and watch this every day. Now, all of us in the office had different parts of the tractor to build. My main part was the mudguard. Now, it might sound strange to think that I spent all day designing just a mudguard, but I had to think about the shape of it so that it didn't hit the wheel, but also kept the mud off the tractor. I had to think about the material that it was made from, and even how it was made. And at one point, I even had to buy the tools for making it, which cost £500,000. So it was very important. I spent lots of time making sure everything was right. Now, I worked there for a few years, but then I moved on to work for another company called Blair's, who made windows. This time my job was not a mechanical engineer designing things, but a manufacturing engineer. So I was looking at actually how the parts were made. Now, Blair's had a big factory where they made around about 150 different windows every day. I had to decide what machines would be needed to make these, how best to put them in the factory, and what machines to use every day to make as much as possible. The company wanted to make as many windows as possible, but it also needed to make them as cheaply as possible because that was how it was going to make money. Now, if I could save a little bit of money on every single window, the company would make a bit more money, and perhaps they could even pay me a little bit more to do my job. Again, after a few years there, I moved again, and the place where I currently work, called 4C Design, and I've been here for 10 years now. Now, it's much smaller than the other companies I've worked for. And another difference is rather than making our own products like tractors or like windows, we actually help other people and other companies design and make products. So we don't actually make anything ourselves here. But the place of work that I have, it's got a small open plan office where we can either work in groups or we can work on our own. And we've also got a workshop where we might make ones, just make ones and twos of things, test things out, try different things that we think might work. So what typically might happen is that someone might come to us and they've got an idea that they want to make something, but not sure what to do. So in one example, somebody came to our company with the idea that they wanted to make and sell electric bikes, but they didn't know what the bikes should look like. They didn't really know how they would work or how to build them. And it was my job as an engineer to try and figure this out. So I had to think about how the parts might work. So here we've got a motor and some gears connecting up to the pedals. We built prototypes to see whether the things would actually work. So once we tried pedaling with it, would it all work as we expected it to? I then start drawing it up on the computer to see if it could all fit together. Here you can see the motor, the gears, and the batteries all fitting inside the frame. And then I'd have to draw up even more, every single detail, to see how it could be made and then get the parts actually made themselves. Now, sometimes we made the parts in our own workshop, and other times, in this example, we got other people with specialist machines to make the parts for us. But in the end, we managed to make a bike, this one here, that could be ridden around. We only made one bike for the person, just to show them how it could be done. And now that they have their one, they're able to try and see if they can start their own company selling these bikes. But I've got lots and lots of variety at my work here, which is really interesting for me, and there's lots to do. So some of the other projects that I've done, this one was for renewable energy, and this is actually a wave energy converter. So this uses waves from the sea to make electricity. It's maybe hard to tell from the picture, but this thing's probably about the size of your classroom, and it was a prototype we made that sat in Loch Ness, and This is a picture of it being tested there with the waves in Loch Ness. This was a product that was actually made and sold in shops. It's a speaker this time, but instead of trying to think about how the part would actually be made, instead it was more how the part should look, what materials it should be, what colors and shapes and sizes would be used. And we sometimes get asked to make really strange contraptions like this one. And believe it or not, this device is actually used to help make medicines for animals. So the sorts of things I do at my work, well, as I said, I can work in a team or on my own. Sometimes it's best to work as a group, and we can all share our skills that we have and combine all our efforts together. Other time it works just to work on my own, especially if I'm maybe drawing things on the computer. As an engineer, you have to come up with new ideas all the time, whether it's to work out a new product or to try and solve a difficult problem. We have to build models. As I said, we've got a workshop here, and we're constantly making things and trying them out and testing them to see what works and what doesn't work. I spend a lot of time drawing parts on the computer, seeing how things fit together and how they might be made, and then also getting parts made as well. So there's lots of different things that I have to do as part of my job as an engineer. And the things that I like best are really having to design new things and as I said, solve difficult problems. We get all sorts of people come into work asking us to come up with new ideas and new ways to solve problems that they have. And the fact that every single day could be slightly different from the day before makes it really interesting. And variety is one of the great things about engineering. I really like drawing on the computer. That's something I spend a lot of time doing. And it's something that the challenge of having to come up with a really difficult thing and make it works great. As I said, a lot of solving of problems, whether it's trying to work out a new way of doing things or fix something that's broken, and thinking about how things are actually made. We take bits apart, look at how they go together and how they might be done better. And finally, the variety of work, all the different things. You've seen some of the pictures of things that I've done there. It really keeps it interesting. So I hope I've been able to show you some of the things that I do, how I managed to get into engineering, what it was that I liked about it, some of the different jobs that are available, and why I think engineering is actually a really good job to do. So if you've got any questions about anything that I've spoken to you about today or anything else, then
thanks for that. Well, a couple of questions have come through already. You have to bear in mind, below, they couldn't hear. They had no sound throughout your thing. So
okay.
But it's rather cheeky what to start with. Can I ask you also to turn on your camera and put yourself full screen so people
All right.
can... Yeah, cheers, mate.
Okay. And if I do.
Aha, excellent. Thank you.
Oh.
So you can see started off with from Balmarnock. How much do you get paid?
How much you get paid? Well, actually, I actually had a quick. If I can very quickly share my screen again, I might have a better answer to that. And hopefully you can see this. Oh, there we go. So I found this. It's maybe 1 or 2 years old, but it's a graph showing how much people in different jobs get paid, because this is an important question. And the longer the line, the more people get paid. And hopefully what you can see is that down near the bottom where all the longer lines are, we've got all the different types of engineering. So actually engineering really is quite a well-paid job compared to other things. And yeah, I know that's important to people. So there we go. I'm going to start going through these now. What are you most proud of? I think one of the projects we did a few years ago now was to make the Queen's baton for the Commonwealth Games when it was in Glasgow. It was 4 years ago now, and our company had to do that. Now, it's a little bit like the Olympic torch, but for the Commonwealth Games, and we had to make this thing. It was given to the Queen, and it was shown on television, so it's probably the thing that most people have seen that I've made. So I think that's the thing I'm most proud of. What were the challenges when building the tractor? Well, one of the big challenges with the tractor is that it has to deal with such rough environments where it's driving through fields, it's really muddy, it's bumpy ground. So anything that was going on, it had to be really strong. As I say, it had to deal with lots of mud flying around. But just simply putting something on wasn't good enough. So it had to be tested lots and lots to make sure that it wouldn't fall off or break as the tractor was driving along. Do you have any, so I think there's one just went through. Do you have any future designs lined up? Well, yes, luckily we get different things coming in all the time. We've found recently we've had a few projects involving lasers and how they can be used. So those are some interesting ones that we've not really done too much in this company before, but looking forward to doing that after Christmas. What subjects help you the most? Well, I think, as I said, sort of maths and science subjects are the ones that probably are the most useful to engineering. But actually, there's I probably use a bit of everything. I have to write reports. I have to draw pictures, so being good at art is also useful. Certainly got colleagues here who are much better than me at that. But it's also important to say that it's not just about being exceptional at these ones. If you just enjoy it and that's what you like to do, then it's a really good idea to think, well, maybe I want to carry those on and do them as a job. How many days a week do I work? Well, I usually work 5 days a week, but I actually have quite flexible working hours in the company I'm at. So I tend to start work fairly early in the morning so I can finish a bit earlier. Some weeks I might not be too busy and I could take a day off, but know that the following week would be really busy, so I might have to work an extra day, and just know that normally it'll all add up at the end. Does engineering involve traveling? It certainly can do, and I was actually very lucky to have to go over to Australia just a couple of months ago to test a product that we're making. So this is something that's going to be used in a farm, particularly out in Australia. And one of the things we had to do was take it out there and test it actually on a farm in Australia, just where the conditions are different. We had to make sure that it would definitely work. We tried it with farmers there. So yes, it can involve traveling. What's your funniest moment at work? I think I've had lots of really silly things when we've tried testing things out. We were asked to, in fact, it was part of the machine for making the animal medicine. We had to work out how to cut open bits of meat. Now, they were, at this point, it was dead animals that were being used, but we had to try and work out the best way to do that. So we had all sorts of saws and knives and tried to cut up bits of meat, which generally involved throwing them all around the workshop. So we had a workshop covered in meat. It was quite funny at the time, although it was a bit of a mess to tidy up. How do you make drawings become real? Well, there's lots of different ways. Sometimes a drawing could just be a quick sketch and all it needs is 2 bits of wood nailed together and that's enough to show what I want. Other times it could be a really complicated part that has to be made. Now, one thing we do use lots of more and more, particularly in the last few years, is 3D printers. And it's very easy nowadays to draw something on the computer, and just as you would press print and send it to your printer to print on paper, we can do exactly the same thing, but it prints out a 3D object for us. And we have some printers in our workshop here. And so one of the easiest ways to do that is just simply to print stuff out. It makes it very quick to check that things work. What's the hardest thing you've worked on? And can your job be confusing? I think one of the hardest things was the wave energy converter that I showed you a picture of. The environment that has to go in is really tough and really tricky. I'm sure you've been to the beach on a stormy day or seen waves crashing against rocks and the water sent up in the air. Now that's what a wave energy converter has to deal with, and trying to make something that's strong enough that it can cope with this, the weather and the waves crashing on it was really tricky. And can it be confusing? I guess it can be confusing and hard, but that's probably one of the reasons I enjoy it, is that actually it really is tricky sometimes, and it really does have to make me think. But managing to work out a tricky problem or find a solution is something that makes it interesting and worthwhile. Has anything you've ever made gone horribly wrong? All the time. We make things to test things out all the time to try and see if they'll work, and it's very often that I can draw a picture of something and think, oh, that's amazing, that's really going to work really well. I go down to the workshop, I make it, and then realize that it just doesn't even work at all. And that happens all the time, but that's part of the learning process. And by doing that, I can go back and think, well, what didn't work about it? Maybe there's some things that did, but being able to just make mistakes and learn from them is a really important way of doing it. It doesn't have to be perfect first time. What made me want to be an engineer? I think there wasn't one moment that suddenly made me think that's definitely what I want to do. I think particularly when I was at secondary school and thinking about the sorts of jobs I wanted to do or what I wanted to study at university, I started looking at different jobs, and really engineering seemed to fit. The aspects of engineering were the types of things that I like doing. I like doing maths and I like doing science, and that seemed to be what engineering involved. What's been the most dangerous thing you've worked on? I guess one of the most dangerous things, we had to try and work out how to make airbags go off. So these are car airbags that if you had a crash in your car, would come off and fill up the bag so that you don't get so hurt in a crash. And we wanted to try and use these to inflate. Well, it's going to be a life raft for a boat, and we thought we could use an airbag to do that, but we had to try and work out how to get them to actually to go off. And if you have ever seen an airbag go off, it doesn't slowly inflate like a balloon. It actually explodes open. It's actually quite dangerous. But we made sure we did it in a safe way. We had protective goggles on and protective equipment so that we could do it safely. What range of materials do you get to use? Anything very strange? Well, I guess anything and everything we use, because all the projects we do are slightly different. We use metals and plastics and foams and rubbers and wood and everything. But what's the most strange material? I think some of the plastics nowadays are so they're very clever materials that can do all sorts of different things, and it's amazing how strong plastic can be. I always think of metal as being far stronger, but actually there's some plastics nowadays that are really strong and can do the job equally as well. If you could work on a design for anything in the world, what would it be? Well, do you know, I think probably cars are kind of exciting thing to work on. Something that everyone can see, everyone uses, and that would be something that would be really interesting to work on. But I suppose what would make it even more exciting would be trying to think of a way that cars could be used where they don't use up so much fossil fuels. So maybe an alternative way that that could be used to power cars. And that's one of the other things that I particularly like about engineering, is that actually I do get a chance to try and make a difference and make the world better, whether it's with renewable energy, or coming up with a way to reduce waste, or hoping to be involved in a project to try and get plastic out of the sea and out of water. And these are the sorts of jobs as an engineer it's really great to work on, to think that I could maybe make a bit of a difference. Have projects ever won awards? If so, what was the award and how did it make you feel? Yeah, I guess we have won a few awards. I think going back to the Queen's Baton I mentioned before for the Commonwealth Games, we won a few awards for that, and that was really pleasing. That it was something that lots of people had seen, and after having seen it, they thought it was good enough that that we should be awarded and recognised for how well we'd done. So I guess it made me extra proud to think that that people had thought we'd done such a good job. Have we ever engineered something that's gone airborne? Well, I guess, yeah, not the whole aeroplane, but we have worked on bits of aeroplane. So nowadays, with new airplanes that are built, as I said, plastics nowadays are so strong that they actually use plastic to make aeroplanes. So instead of the wings being metal, they're actually made of plastic. But one of the difficult things is how to join the bits of plastic together. And so we worked with a company who make aeroplanes for how they could join the bits of wings together so that they don't come apart when you're flying. And what's my favorite type of engineering? I think I really like the mechanical side of things. So looking at mechanisms, how things work, how parts can work together to make something happen. So whether it's using levers or gears, these sorts of things that can make a really nice mechanism that works well. And have I done a project on pollution? Well, as I said, we're just hopefully trying to start one now, which will look at plastic in the sea, because it's obviously a very big issue that we've seen, and trying to work out how you can get the plastic out of sea. It's something quite excited to work on, but also very tricky, because it's not just an easy thing to do. But again, actually having a really difficult challenge is something that makes my job quite exciting. Are there any jobs that you haven't enjoyed so much? I think there's always things that are better than others. I mean, there are some days in here that are great fun, and it just doesn't seem like a job sometimes. It just seems like having fun. But then there's other days when it's doing things that are a bit boring, and but has to be done. And the sorts of things that I don't enjoy so much are writing reports. But that's not to say they're not important, and they have to get done. So I just accept that some days are really exciting and some days are the report writing days. How many inventions have you worked on? Oh, well, at my time at 4C, we probably have about 40 different projects every year. So maybe 400 different projects and inventions that we've worked on just in my time here. How long do projects take? And do you enjoy the office side of the job? Well, projects can vary wildly. We've got one that's starting to get near the end now, but it's taken 9 years to get there. Other ones might only take a week. And it really just depends on what's involved. Do I enjoy the office side of the job? Well, as I said, some things like report writing aren't so interesting for me, but I do enjoy working in an office and working with other people around me. As I said, I get to do a lot of my job involves working in groups and in teams, and being able to work with other people definitely makes the job more enjoyable. The hardest project we've worked on, and have had any accidents? As I said, one of the hardest things was working on the wave energy converter, just simply because the effort to try and make it strong enough. Have I had any accidents? I don't think I have had any accidents. It's very important to recognize that some things I do are a little bit dangerous, but that most of the time there's ways that you can make sure that you don't have accidents. I mean, for instance, I can use some of the machines in the workshop. There's drills and saws and all sorts where if I wasn't careful, then I could very easily have an accident, but by making sure I'm careful, that doesn't need to happen. Have you ever given up on a job and not been able to complete it? I can't think of one off the top of my head, but definitely that's the sort of thing that can happen. There's, in fact, I think I did mention we tried to use airbags to inflate a life raft, and that was something where we hoped that would work, but once we tried it out, we found that really it didn't work like we thought it might. And actually, part of that was then going back to the client, the company who come to us and say, do you know, we can't find the solution to this, but that was okay to go back to them and say that, and instead of just carrying on and trying and trying and trying and hoping for the best, we instead looked at it a different way and tried to find a different way to get around it. So sometimes you have to say, do you know, I'm not sure that it is going to work, and maybe leave it and try something else. Who inspires you? Again, I can't remember ever seeing an engineer that inspired me to get into engineering. And probably the one person that I can think of being around at the time when I was at school was someone called Stephen Salter, and he was trying to develop renewable energy and wave power at that time. And some of his ideas are very, very clever. We didn't really manage to make them work. The ideas that he had behind it were amazing, and you know, I've been fortunate to work in some wave energy devices too, and see some of the problems he had. But I guess, yeah, he's quite an inspirational character to see how hard he tried to do different things. How long have you been an engineer? Well, I suppose it depends when you would say, when did I become an engineer? I graduated from university with an engineering degree in 2002, so that would make it 16 years ago. I suppose at that point I could have been called an engineer. After I'd worked a few years later than that, so maybe it was around 2005, I got chartership, which means I can call myself a chartered engineer. So you could say maybe it's been that long, but actually I think probably even when I was at primary school, I was to some extent an engineer, in that I liked building things, taking things apart, finding how things worked. So actually I think I've probably been an engineer a little bit all my life. And then another one about inspiring. Can you be an engineer if you're a girl too? Of course you can. I mean, certainly at the moment there are far more boys go into engineering than girls do, but there is absolutely no reason why it would make a difference. And I think that's probably just something that traditionally engineering's been seen as a boys' job, and other jobs have been seen as girls' jobs. But there's no real reason why it should be that way. And certainly we're finding there are more and more women in engineering jobs. Where I work, I guess I'm quite lucky that where I work there are It's not quite half and half, but we've got quite a few women who work here. So it's definitely something for males and females. And looks like a few people having to leave now.
Sorry, there I was talking away. Then I forgot I was on mute.
Okay.
So, is there any more questions, anybody? Just a couple from further up, and I'm not sure whether you actually, from Peel Primary. What school subjects help you do your work? Yeah.
What school subjects help me do my work?
Yeah.
Well, certainly maths and science are the ones that I probably use most, but to some extent, I probably use every subject at some point in my job. As I say, I have to write reports, and having done English, that helps. I have to draw pictures. Having done some art, that helps. Even things like, I suppose, giving presentations like this one, or to some of the companies we work with. Even something like drama probably makes some difference. So everything helps a little bit, but maths, physics are the main school subjects that I really use every day. Another one here, do you use designs already made, or do you come up with your own ideas? Well, both, I suppose, is the answer there. It depends. Sometimes we get people come to us with something they've already designed, but just don't quite know how to finish it off and get it made. Maybe make it how to get it made in the right way. Other times, people come with just a general idea, and they require us to come up with a brand new way of doing it. But actually, one of the things we can do, it's not really cheating, but it's amazing how often that something that somebody's done somewhere can be used somewhere else. So, for instance, a couple of projects I've mentioned there, we were working on a wave energy converter that tried to make energy from waves, and one of the things that we used there was a big rubbery sheet and they had trouble with it always tearing, and they needed to try and find another material that they could use, and they asked us to help them with that. Now, at the same time, we were looking at life rafts and inflatable life rafts. And so we were able to make a connection between the inflatable life rafts and materials used for them and the wave energy converter, and say, well, actually, maybe the material that's used for the life raft could be used somewhere else. And quite often it's finding something that's used somewhere and putting it in a new place. Is part of just being able to see that. That's something we can do. Where do you get your materials and resources? Do you have special companies you work with? Yes, so we have lots of different companies who provide us with all sorts of different things. Because we don't really know what projects we're doing all the time, then it does change. But we at 4C, where I work, we have a small workshop where we can do some things ourselves, but a lot of things we just aren't able to do, we aren't able to make. So we have lots of other companies that we work with, sometimes just once, sometimes we work with them all the time. And they'll have specialist skills or specialist machines that can make things that we just can't do. How do you advertise your work? Well, I guess that's quite interesting. We, as 4C, we tend not to advertise that much, really, other than just speaking to people and talking to people. But we rely a lot on people we work with either coming back and asking us to do more work for their company, or maybe recommending us to some of their friends who will work at different companies. And that's mainly how we get our work, either through people who've already worked with us, or they know someone who has that hopefully we've done a good job for. And what's your favourite design you've made? Well, certainly I mentioned the Queen's baton before, but I think one of the other things that I've enjoyed doing were making the bike. I enjoy cycling, and to be able to make a bike from nothing at all. When we were first asked to do it, he really didn't have any idea what he wanted, and to go from a starting point with a blank piece of paper all the way up to an electric bike that worked was really quite was something that I really enjoyed, and it was really pleasing at the end to have something that worked.
Did anything happen with that bike?
Sorry?
Did anything happen with the bike, John?
Well, it's still going. He's still trying to. He's just trying to raise some money to start to start making it. Really, that's where it's left. I think in my presentation I mentioned that we don't make things here. We tend to help other people make things. So it's quite often at the point of designing the first one, we then hand it back to them, and they go off and make it. So, and that's the case in this one.
Right. So was you pedal for a bit, then you hit a hill, then it goes up the hill, that sort of thing?
Yeah, that's so. Yeah, if you're cycling up a hill or even on the flat, it just helps you out. So you still have to pedal, but it just makes it easier. So if you're pedaling up a hill, it actually feels like you're just pedaling on the flat with a little bit of a wind behind you.
Oh wow, sounds good.
Yeah, it makes it much easier.
So it's Lingy House, right? Thank you, Lingy House. So, Peel are off as well. Thank you all very much.
Okay.
Thank you, Peel.
Right.
And thank you, John.
Okay.
That's about everything's going. While I've got you here,
Yep.
Can I ask you if you can do another one in March? Is it March?
Yeah, that's all right. Yeah.
Where have I got you down for? Oh, actually, no, it's January. The 28th. I'll send you an email.
Okay, let me check.
28th of January at 1:30.
Yeah.
All right. Brilliant. Well, cheers, John.
Okay,
thank you very much, mate.
Okay, that's all right.
It turns out there were almost 1,971.
971. Okay, well that's I'll see if I can get a wee tweet out about that, because that's something I should really be quite proud of that too, really.
Yeah. Oh yeah, very much so. Yeah. Brilliant.
Right.
All right, mate. Have a great weekend and a great Christmas.
Yeah. Well, Andrew, and we'll speak to you soon.
All right, mate. Bye.
Okay. Bye.